All right, going
Recording
live.
in progress.
Hey everyone, it's Monday, January 24th. Back to Computer Science 1, spring of 2022. We're going to continue Chapter 2 and get a good little start on Chapter 3 today. Let's get a program up and running. Let's go to Visual Studios. And I'll do open a project, just use an old one. Let's see, my CSCI labs. We'll just go to Project 1. And I'll open that up. If you want to create a new one, or if you're doing your own lecture notes. Some students do lecture notes. If you're trying to do lecture notes in Visual Studios, you kind of need to comment out every main that you do if you're trying to keep an ongoing one, because you can't have two mains. It's really going to throw your stuff off. Why is that not minimizing? Oh, well, okay, it's not. Let me just delete all this crap. So we start with a, oops, do. Clear out the main. And we're doing Chapter 2, Part B today. So, in the past, we had covered variables last time, data types like integer and double, and we did char. So, as a quick reminder, char x equals a, and when we do it, we need single quotes around it. And we can ask the user to populate that. So, like, please enter a character. And I'm not going to say, like, please enter a char, because users don't know what chars are generally. I'll just say, please enter a character. And remember, we would do cin. We use the extraction operator, which is funny, because to me, we're, like, inserting something, but we're extracting it, or cin x. Okay? And let's run it. And let's say the person didn't pay character. Please enter a character, Mickey Mouse. That's a character. So it entered just fine. But let's see what happens if we do the same thing and then see out X afterwards. Let's do a insert, or not, N. So /n, /n like that. In a string literal or n line, both make new lines. As a just quick reminder, I'm going to do the same thing, and I entered a character, Buzz Lightyear this time. And all I got was B. So what did it do? It just took out the first character and it stopped working. So this cin right here, the cin in general is only good for the fundamental data types. A full name, like Buzz Lightyear, we'll just say Buzz for here, is a string of characters. And we call that the data type string. Data type string. To use it, we have to do this. We need to include another library. So I'm going to do include, and we're going to include the string library. And once we include that, that gives us a lot of new options. So let's edit this up a little bit. Let me make a new one. Let me make a string. We'll call it my name, or just do name. And we're not going to assign it any value to start off with. But now we'll ask the user for something here. Please enter a name. And I'll do the same thing. I'll cin into the name. And when we're done, we will C out the name. Let's take a look at what happens here. So we got our string name. We're going to ask for input. Please enter a name. I'm going to go with, well, hell, let's go with my name. David Richard Jones. What happened? Why did it miss the D? Oh, I had a previous CN up there. So notice it didn't even grab the D. It grabbed David, which shows a little problem with CN in general. One of the problems is as soon as it got to a space, it stopped. So it stopped recording at a space. And it was missing the first letter. And this happens often when you have a CN and you're trying to get a string of characters. When you're doing it, it enters the enter character as one of the characters, and it causes a problem, and we can use CN ignore. Help with that character problem. Let's try that again. Oh wow, I ignored two characters. What other thing am I missing, Adrian? What else do you put with CN ignore? Let me comment out this one up here. I'll get back to you. There's another thing that goes with CN ignore. I'm brain farting on it though. We'll comment those out, run it. And there, now it grabbed the full first name, but it stopped at the space. So how do we deal with this? So string has another command in it. String has the getline command in it. And it's all lowercase. And the way you're going to use it is you're going to string, it'll have two components. The first component is going to be the input channel. And you'll enter a comma, and then you'll put the variable to store it in. Now, as of now, the only input channel we know is CN. So that's what we're going to use. Getline CN common name. I'm going to comment out that CN up there. And we got that Getline right there. Let's see what happens. Oh, I know part of the problem. It was doing. Let's comment those out too. That might have been part of the problem. So we got the name, our C out, our prompt to get it in. And there, now we've recorded the full name. So your first little bit of information right there is the get line. You want to use that. But let's try something different. Or let's do something else afterwards. Let's make another value like integer. Let's call it my value. And let's do a prompt for that. Please enter your favorite number. That sounds like a good way to get a number. And we'll do Getline cin my value. And I got a red line underneath it. No instance of overload function Getline matches the argument list. Getline is for strings only. So this one doesn't work. So you use cin for the regular stuff, Getline for this. I'll comment that out because it didn't work. Just because I said a name, let's change. Let's make that a number instead. Let's comment all that out, or comment that one out. And now let's make a value. String we'll do string my value now. And now we can do the Getline cin. And it works just fine. Well, Buzz Lightyear's favorite number would probably be infinity, but let's say it's 7. Oh, I didn't see out. So when you're testing your code like this every once in a while to see stuff, you'll find that you didn't show everything. See out my value. Let me do a line in there, end line in there. Now see out my value. We'll say Buzz and 7. So I can store 7 in there just fine. If I do something like int your value equals 7, these are two different things. It's important to know that. So numbers stored as strings aren't used in the same fashion as numbers stored as integers or doubles. And we can show that. I'll leave that 7 alone. I'll do this C out again. And I'll cast it to an integer. We talked about casting last week. Oh, shit. Wants to do that. You have to do it character by character. This requires doing it character by character, which requires arrays, and we are not ready to do that yet. But it does have a different value, even the number 7. One way we can show that would be cout int char. Ooh. Let's say char x equals 7 like that. And cout int x. Gotta watch those parentheses, gotta watch your colons, gotta watch your double less thans or greater than signs, gotta make sure we have the right stuff in there. Everything's good. I'm just gonna use, when I do my value, I'm gonna type in 7 just to show that they generate different things. So if you want the actual integer value of 7 as a character, it's 55. That's just pointing out how they're different. So it's good to keep in mind. Any questions on that so far? All right, I'm going to comment that all out. Oh, well, let's just leave it alone. Let's open up a new one. I am going to go over and grab, let's look at our lecture notes that we had. And we'll look at the notes for 2B. So this is notes for obtaining strings from user using CN. Let's just copy and paste this and I'll make a new, open up a new program. Lecture for 2B. Lecture 2, part B. Create. And we got to add a new source file. I'll just call it source. I'll make sure it's a CPP file. And I can paste it here. And let's just take a look at what's going on with it. Let's just run it and see what happens. See what it's asking. And then we'll go through it. Please enter your full name. My name is, let's change it up. James Tiberius Kirk. Your name is James from the keyboard. Here's a number that rounded to 2 decimal places. That's an interesting thing. Let's take a look at what they're doing. So, we've got the IO stream. They've included string. They've included the IO manip. And why did they do that? If you remember, when we started, if you don't set the precision, like we just did, in fact, we'll do it before the fixing it. Here's a number not rounded. And they're trying to print out 5.66666 with a bunch of sixes. And it goes to, looks like 1, 2, 3, 4, 5 decimal places. So it defaults is to 5. And this one sets it to 2. Sets to 2 decimal places. And David brought this up last week with a question about Sig Figs. So let's change that C out. Let's do it before it. Let me copy and paste this before this. And we're going to get rid of the fixed part. Here's a number with 2 digits. So the difference between set precision and then fixed set precision. With 2 digits is 5.7. It does Sig Figs. Now, his question was, how can we get the program to determine how many we need from the other numbers we enter? We'll do that later on when we're doing more stuff with controls and stuff like that. But this is a start. So this is Sig Figs. it sets to 2 digits or significant figures. We'll do more with this later. And it doesn't look like there's a whole lot of other stuff going on in there. They've got the CN, they had the Getline commented out. So when I entered James Tiberius Kirk, it didn't actually use it. So maybe we should comment out CN. And comment that one out and uncomment these two. What the? I highlighted you. Uncomment. Actually, let's leave them all uncommented. There we go. Just to point out the difference between CN and Getline. It just says David. Ooh, it glitched. Notice it just took the whatever I typed afterwards as the input. So that has to do with the CN ignore, and they have CN clear, and there's some other commands. We'll cover a little bit more later. Comment those out. And as we showed earlier, using the get line gives you everything you wanted. So now it says my name is David Jones from the keyboard. That lab's not very exciting. So let's see what else we had in the notes. Next, we're going to fix the following program that produces incorrect results. So let's just copy this whole bad boy over and put that in. And let's just run it to see what it does, get an idea of what it does before we tear it apart. Please enter the customer's name. Jack Daniels. Number of square feet to be covered with mulch. Looks like Jack Daniels is a gardener. Let's just say he's got a house around town and he's not a farmer. Maybe a 5-foot by 10-foot garden would be 50 square feet. So maybe 50 square feet. Let's see, he wants, well, you don't need a lot of mulch. It doesn't need to be super deep. 3 inches sound good. It says number of cubic yards needed is 0. Price per cubic yard is 22. Total price is 0. Well, we know it shouldn't be 0. And apparently this mulch is sold by the cubic yard. So let's go through and look at what's going on in the program and see what we can do to fix it. So it does say it uses the number of cubic yards of mulch a customer needs and its price. It's including the IO stream. It's including string. And then it's got const double price per cubic yard equals 22. I guess that's so like the clerk at the Lowe's doesn't fuck up and enter the price for him and give him a discounted price or too expensive of a price. So they made it a global constant. And then we get to our main program. The variables are declared at the beginning. I like that. So square feet and cubic feet are both recorded as doubles, as is cubic yard and total price. The depth is recorded as an integer, and name is a string, of course. And we're going to go through it. We get input from the user. Yes, that's what we're doing here. We ask the customer their name, and we use Getline to put it in. Number of square feet to be covered with mulch. We did C in there. That worked as well, square feet. C in depth. I don't know if those worked or not. Let's just see those out. Let's run this again and see if that's the problem. So we'll run that real quick, and that might be a problem. There's something going on there. I said 50. I said 3. I took in the 50 and the 3 correctly. So those aren't the problems. So that's not it. Let's see. So is it in the calculations? Cubic feet. So a cubic foot is, let's just draw it on the screen real quick. How does a cubic foot would be? Are you drawing? Oh, shit. This isn't that type of pen. So a cubic foot is like that. Wow, I'm doing this with a mouse. And so it would be 12 inches on each side. Here, here, and along the height. So cubic feet would be square feet. Square feet would be just this side right here, the area of one thing, and then you multiply it by the depth, which will be the vertical height. But we don't want depth in inches because that's how depth would be in inches, and we want cubic feet. So we're going to divide depth by inches, and that'll turn that to feet. So depth divided by 12 does make that feet. So square feet times another foot would be cubic feet. That matches. Math is good there. Let's see, cubic yards. A yard is 3 feet. This might be easier to type. So let's see. A yard is 3 feet. So if we want to do yard times yard times yard for a cubic yard, that's going to equal 3 feet times 3 feet. I guess I don't need the parentheses each time. Times 3 feet, which would be 27 feet cubed. So 1 cubic yard is 27 cubic feet. So if I want to solve for cubic feet there, that matches up. A cubic yard, if we're only given feet, is going to be 1/27th of a cubic foot. That one matches up. And total price should be the amount times the value. That matches up too. So our error must be in the display. Let's print out the name. That worked. Print out the cubic yards. That worked. Price per cubic yard. That's just a constant. That was given. That's not going to fuck up. And total price was calculated right here. And the math was good here. Math is good in all of these. So where is the error? Why is it not working?
Is it because we're multiplying a double by an integer?
Yeah. In more particular, it's not that it's a double times an integer. But the integer part happens. Right here, we've got depth divided by 12 in parentheses. This operation happens first. And I've got an integer divided by an integer. Remember, when we do this, it rounds down. And we can test that. Let's do C out. Wow, let's do it up there. Depth divided by 12. Because I don't need that space there. But I'll put one after that. $50 square feet. We're going to do 3 inches. And depth of 3 divided by 12 is 0. So that's where our problem is, right there. Depth divided by 12, it's happening first. So that's causing square feet to be multiplied by 0. And so it's still doing all the math correctly, but we ended up with a 0 in there. So well, does changing it, taking it out of the parentheses help? The math should still work. It's pissed because I didn't close it before. Let me try it again. $50 square feet again. Oh, let's go 100. I know the math easy pretty well there. Let's go 6 inches. That would be half. So 100, half of 100 would be 50. Dividing 50 by 27 should be close to 2. So it's working fine there. So that's one possible solution.
Couldn't you just also make just
Go ahead. Lewis, did you want to say something?
Sorry, I'm just speaking out loud. I didn't realize I was muted. I wasn't muted.
Well, if you're thinking out
Out
loud,
loud.
think with us. Come on, sure. What else could we do?
I was thinking, couldn't you just switch out the integer depths and change it to double? That's what I was thinking.
We could definitely do that. We could make depth a double. We could hard code depth as a double. Or we could do it on the spot. Doing it on the spot, options are if I do 12.0, using 12.0 is making it an implicit double. Implicitly. Or I could just flat out say double depth or double 12. And that's an explicit cast. But I made an assumption that they were going to want to use whole inches, but if someone wanted to do 2.5 inches, maybe we should just make it a double. Does everything work fine now? Let's give it a try. David, we already know it should have been, oh, let's see.
Star of.
What?
Nothing.
20, what's 27 times 12? I don't want, fuck it. We'll go back to 106 inches. So that's looking good. Let's make sure of that. Where's my calculator? So 100 divided by, or times 6, or a half a foot would be 50 cubic feet. And 50 divided by 27 is 1.85 repeating. And if I multiply that by 22, I do get $3. Wait. Something's off. I think I just typed something wrong in my thing. Why is my calculator all acting crazy? Oh. There we go. I'm getting what they got. 40.74074 repeating. Okay, so it's working now. If this is a program that is used, it sounds like it's for like a cashier though, right? Because it's asking for the customer's name and stuff like that. So maybe we should make it look a little bit better. Let's make it pretty. Now that we got the programming work, let's make it pretty. I'm going to run it again to see where spacing should happen. Well, I need to get rid of this 0.25. That was I put in there to error test. That seems like an awful lot of information. Number of cubic yard needs is 0.46. That seems like a lot. We definitely don't want that many decimal places right there, right? Total price, 10 what? I'm assuming $10 because that's what the price per cubic yard said. So let's get rid of that CO that we did there. Let's get rid of that. Let's see. Price per. Well, we wanted to change the precision, right?
Yeah, I said right above the total price. That way we rounded after the cubic yards.
I'm gonna get there. I wanted to show what happens if you don't.
Oh.
But I'm glad that's the best spot to put it. So David said put it down here. I will copy and put it there real quick. And why is it red?
Because you didn't include IO manip.
I didn't include IO manip. So I'll see out there. Turn that off real quick. And let's just walk through what happens if I put the precision. Oh, I wanted to have a $sign there too. So I'm going to add a $sign there. Let's say you put it early. It says number of cubic yards 1.85. Is that going to change it any? I'm going to do 1.85 times 22. Now I get 40.7, $40.70. So if we have a particularly savvy customer or someone that checks their math later on, that total price it's not reflecting correctly. So as David said, let's put that down below. Let's put it down after we've shown the other stuff. The only part we really care about it is down here. And it felt like there was an extra space in there somewhere. I don't like that space right there. What is this space doing? I don't even know if we need that many lines between it. Let's take a look. Tom Cruise. I like sticking with the same numbers when I'm doing stuff, when I'm testing, because I know what the response should be. All right, it says the full name. It's showing the number of cubic yards now. And now if I was a customer that was particularly savvy, and I said 22 times 1.85, 185, I would get $40.74. So that would look good to me. And so I think that one's solid. So let's see what else we can look at real quick. Modules before I hit or functions. Let me do something real quick. Programming. joining on my tablet where it's easier, right? And then I will share screen there. Share screen. All right, so one of the labs is on fractions. Oh, I guess I should show that real quick. So we'll steal that back. And we'll go look at the fraction lab real quick. So when you're doing this, trying to figure out what goes where, if you've forgotten how fractions and division and shit works, you probably haven't done it in a while by hand. Let's just take a look at that real quick. And we'll use the 27 and 4 that it's talking about right here. So it's doing, we're looking at 27 divided by 4. Ooh. Let's go with blue. That's going to show it better. So when we're doing that, we're dividing the 4 into the 27. Ooh. Let's get that bar out of the way. There we go. Okay, we're going 4 into 27. And 4 doesn't go into 2, but it goes into 27 6 times. And 6 times 24 is 24. And we subtract, we get a 3. And so the number is 6 3/4. So the actual quotient you get is the whole number. So division gives the whole number. And doing division where you get a remainder is the numerator. And how do we do a remainder? How do we find a remainder in division in CSCI or in C++? Anyone remember? The percent sign, yeah. So 27, oops, 27 divided by 4 in the computer is going to give you the 6 if you do this as integer division. And then if we do 27 modulo 4, that's going to give us the remainder. So this will be our numerator. And then the divisor, what you're dividing by is the denominator. So that's just a quick reminder for that. Let's go back and take a look at function. Is there any questions on strings and stuff like that? All right, let's take a look at functions. So we'll hit that in a second. Let me. Oh, I could probably talk more on the. Do stuff more over here. So I've got a whiteboard. We're starting chapter 3 or module 3. It's on functions. And recall from math, we often use stuff like f parentheses x equals, like, let's give a function. Let's use x squared. So this is my input. And this is the actual function or output once something's put in. So if I put in like f of -2, I've got -2 squared is 4. So that would be my output. And input is -2. And we tended to name a lot of functions like that. We would use f of x. We did g of x. Let's say g of x is x cubed. H of x is x to the 4th. So CSCI is similar, or C++ is similar. So let's go and look at the similarities there. We'll program that up. Before I use theirs, let's just start my own. Let's make another new one. We'll call this lecture 3A. Add a new source code CPP. And we got lecture 3A on functions. We're going to include our good stuff. We need the IO stream. We want to do using namespace. And we're going to do int main void. Oh, look at that. I've got something in the front and then something in parentheses. Guess what? Main is a function. It's the required one, the thing that we need. But let's program up the f of x squared. Let's do, in fact, let's do all of them. We did f of x equals x squared. Let's do g of x equals x cubed. And h of x equals x to the 4th. It still follows the same setup. I need an input and an output. And the way we write it up is we write up the output data type. And then we're going to do name of function, parentheses, input data type. So, and since it's going to be a function, I'm going to do it outside of it. Let's just say double, since I want it to not be an integer, I'm going to say double f, and then we're going to have a double input. And I'm going to use arg. And I'll do my parentheses just like the main has. I chose arg for argument. It's what the input is called in a function. And it tends to not be used in the main is why. So I won't get mixed up looking at things like that. So I can leave it as that. So what this is doing is the function takes in argument, takes in arg, and we want to return arg squared. So let me just make sure this works real quick without doing a square first, because I want to talk about something else. What this is called. Here I'm just setting up a generic function to see if it works. I'm going to come down into the main, and I'm going to say cout f of 10. End line, and I need a return of 0. So my function is taking in 10 as an input. I called it f, and it should return 12.34. And it did. So it didn't square anything. And the reason why I do this is called a function stub. It's a placeholder for a larger program. Often to be added later. Now, we're going to add it right now because, let's face it, coding up this is pretty easy. So I will comment out that line. And let's just do one. So let's make a double. We'll call it answer. And answer should be argument times argument. That would give us a square. And then I want to return answer. Good, so I've got my function. It's got a curly brace to start and a curly brace to end. Input double argument. Output is a double. And now I can do the same thing here. I will just see out f of 10. And we know what 10 squared should be. It should be 100. And it gives me 100. Okay? So that's how functions work. So let's do the g of x and the h of x. So I can double.
Can I ask a question here?
Yes, please.
So the other day when we were playing with functions, you did the function down below main and then did prototype up above.
Yeah, I'm getting to that.
Is it okay?
I'm getting to that. You can do it up above and have nothing to below, and it works just fine. And I kind of wanted to give you a little illustration of how that's going to end up looking. G was the cubic function. So I don't need to make a double here. I can actually just go directly to returning it. I can do arg times arg times arg. And that should work. And I guess I'll need to see out here G of 10. I'm using numbers that are pretty easy to know. And let's do the H real quick too. Oop. And let's code up the H. So we put it in parentheses, our input. If you have more than one input, you'll go in parentheses. We'll be doing stuff like that later. The right an IDE like Visual Studios, notice it. I didn't type this end brace. I like that it auto does that for me. Here I want to return argument to the 4th power. And notice how terrible that looks. Arg dot like that. I'm going to put some spaces in so it makes it a little easier to read. Readability is very important, even just for yourself. And I'm going to tell the user what this does here. H is a quartic function, or returns argument to the fourth power. And that all works. We know when you take 10 to a power, it's just the power with that number of zeros. So 10 to the third is 1,000. 10 to the fourth is 10,000. It's working all good. So back to David's comment. I'm doing them all above here. I'm going to undo this part in a second, but just to simulate. Oh, hell, let's do this. I am going to open another folder. I want you to see how this can look. It should be on my desktop. I've been working with the Friday Night Lab group. I've got the team. We were doing a startup of like the whole MIT team. We're trying to do blackjack. So we were coding up a blackjack game. And that should be in my CSCI projects. And I wasn't the one doing the coding. I was letting the student do the coding. I explained the blackjack and let him go. Where is it? Why is it not showing it? What the hell's going on? Is it in debug? Nope. Okay, I know it's there. It should have been right there. Oh, maybe I can right click this one. There we go. There's a point to this. So this is the blackjack code or blackjack game that we made. And we got a whole, there were so many card values that we did it on multiple lines rather than trying to do 52 cards on one line. We got one for the card names as strings. Got a whole bunch of variables. The asterisk means something we'll go over later. Then we've got a function here for prompt for int. I don't even recall what that's for. I got to read the code later. There's a code for get game state. This was to allow the player to enter multiple, like how more than one deck. And I'm scrolling down. Where the fuck is it? Where's the actual program? I get down here. Still scrolling. Still scrolling. I don't see main yet. This is the run a single round function. Where is it? There's the main right here. 248 lines down. It's got 2 arguments coming in. And the main is all of 20 lines, 25 lines or so. But it's at the very end. It's a little hard to read that, I think. So that's why we do what David was talking about and what I went over last time. I'll close that. We'll go into this one. So this can get cluttered up here. We will place prototypes of functions up here. And implement them below the main program. So to do that, I can copy, the easiest way is if you've done all the programs above. I'm just going to copy them all down below. And I might even make a little area that says, I'll throw some asterisks in so it's easy to spot. Function implementations. Throw some more asterisks in. So when you're reading the code, it acts as a divider. And then now that they're all placed below, all I've got to do is have the input, the name of the function, and I don't need the actual code. So I can comment that out. I didn't want to comment, and let's see if I can do that. I'm going to just come out this part. And just end it with a semicolon. So output, name, input. And I'll do that on each of these. So I'll say double G, and we'll comment the rest out. Comment these out. And I'm only commenting them out because I'm going to upload this as lecture notes for people that weren't here. So I want them to see the whole process. They can follow through with it. Oh, shit, hit play. It caused a problem because the function's defined above and below. And it's got some error. I don't need that there. So comment that out. There we go. So I've got double F, double arg, double G, double arg, double H, double arg. And down below, they're all implemented. And I can do the same thing again. And it still worked. So everything works fine there. And notice I used arg for all of them. So what's going on there is I use arg for all of them. Because that variable has something called function scope. The input has something called function scope. And what function scope is it's like that function is its turf, its house, its boss there. It's the boss there. And so it can have its own name there. Like I'm David. I'm the boss of my house, at least while my wife's asleep. I don't know if David's the boss of his house, but he's got the same name as me. We could call his place David's house, and my place is David's house, which is confusing on the outside. But if we're standing inside of his house, and I say David's house, it's kind of obvious I'm talking about him. So that's the idea there. Inside of it, we can just use arg. Now, this can get a little tedious. I'm going to, let's see, what am I going to do? I'm going to copy this. Oops. Just to show a little bit better what it can look like. So if I cut that out real quick, look how clean that looks. I got my include IO stream. I've got using namespace. I've got the names of my functions, and then the main just starts up right away. And if I really need to know the details of what's going on in the functions, I can come down and look for them. Okay? So that's the idea of doing that prototypes up there. You might actually state these are function prototypes, at least while you're learning. Implementations below. I'm going to put that back in for now. But it looks real pretty. Something else to point out. F, G, and H don't really tell me a goddamn thing, do they? Looking at those without being able to look at it, I don't know what any of those means. So, unlike mathematics, we can use whole names for functions. So let's just change it. F was the square function, so let's call it the squaring function. G was the cubing function, let's call it the cubing function. I mean, I could call it something as simple as cube, but that might get confused as something that wow, is there a word for doing the fourth power? Fourth power function, let's call it that. Now, if I try to run, I've just changed the names here. I try to run it and there's an error because these prototypes are not listed down below. So, something else you can do, I'm going to undo this last bit that I did. Let's change this back to H. And this does not, oh. Yeah, let's see if it works. Having just a single H might not. If you highlight it and you do right click, rename, I should be able to type the new name here. So fourth power function. And if I do rename, like this is Visual Studios, hopefully it works. I'm going to apply it. And it changed it here in the code. And notice it changed it down here. So that's probably an easier way to do this squaring and cubing thing too. Changes back. And then I'm going to change F to squaring function. And I'm going to change G to cubing function. Right click, rename. This is in Visual Studios 2022. Other IDEs might have it. But now my prototypes say squaring, cubing, fourth power. And then where I call on them in my main, it says the same thing. It replaced them all there. And they've all been renamed down here as well. So that's a handy way of renaming them. And now the function is reflective of what is in it. If I just see this, I know right away what type of functions are being called here. The name gives it away where I don't have to go look. So that's worth keeping in mind. Use names that are applicable. And you're like, oh, Mr. Jones, that's so long to type. If you're using something like Microsoft Visual Studios, if I wanted to see out the fourth power one, that's a long one to type. Let's see when the IntelliSense kicks in. I'm going to type F-O-U. Look, F-O-U, and it pops up the name. And I hit tab and it fills it in. And I can tell it, okay, let's send in 2. To the fourth power is 16. It works as intended. But you can use long names, and IntelliSense kicks in. It figures out where you're going with it, and will start filling it in for you. It's really handy. Now, ideally, you're typing this all up without using that, but let's be realistic. In today's world, that's not going to happen. So let's just make sure you know how to use it like that. It can speed up stuff for you. What if I want the argument to the 100th power? You know what? This is just ugly. I'm going to delete it. What if I want the argument to the 100 power? Do I want to type arg times arg times arg times arg times and do that 100 times? Type out by hand. Hell to the no. Not doing it. So there's got to be something in the C++ language that does it. And so let's come over here and look at C++. And I'm trying to do some math stuff, so let's just search for math. Oh, that's ugly. I want to do reference article. C++, when we get after all of these like ads, the first thing we see is CMath. So that's the library name we're going to include. We're going to include CMath. Notice it's got all sorts of functions in here. You got your trig functions. You've got your inverse trig functions or your arc functions. You've got your hyperbolic functions, hyperbolic trigs. You can do exponentials like e to the x. We can do logarithmic functions. Power, raises to a power. That's the one we want here. Look, there's one for square root, cube root, hypotenuse. But hypotenuse is so easy. We don't really need that. Fuck all that. One's for rounding up, ceiling, rounding down is floor. So there's a lot of neat stuff in here you might come back and look at later, but we're looking at power. We want to use the power function. And I know I got to include CMath, but let's just go look at what the CMath is. Let's go with the highest addition one we're looking at. The base one started as just double output, double base, double exponent. So it takes two arguments, a base and an exponent. They're both double. The newest version, double is the top line, so that's the default one. But you can do floats and other type of stuff. Come down and look at the code. They've got 4.73 to the 12th power, and they're doing POW 4.73, 12. That's kind of what we're interested in. So let's apply that to our stuff. So I want to double output, and we'll call it 100th power. And we'll take in an argument. And we said we needed to include the include CMath. So I'm going to include the CMath function. And it said we're going to do power. It was power, base, exponent. That was how the command worked. So the base is going to be the argument sent in. So I want to return. I can do answer for now. Answer equals, I'm going to call on the power function in the CMath library. I got to tell it I want to use the argument. And then the power I've opted to use is 100. And we'll return the answer. And I said answer, but I didn't tell it what answer was. Answer is a double. And I want to implement it down below, so let me copy this and put that down at the bottom. And then I'll come up here and I'll make sure I prototype it up here. Oops, semicolon. And now we'll do, ooh, this could get ugly real fast. Let's go with one. And then I'm going to try it with 2. I think 2 to 100th power is going to break it, though. But I know 1 to any power is 1, so that worked. Let's change it to 2. Does it break it? No, it didn't. Good. So 2 to the 100th power is 1.26 times 10 to the 30th power. That's some Avogadro's number setting right there. Getting really high in those exponents. But that's how we can do stuff like that. So we're going to put prototypes up top. And if you want to code them up top in the first place like I did and then just move them later, and then put the implementations down below. It works really well, and then you just call on them in here. Let's see. So now that I got the C math, I could actually go down here and change some of this shit. Instead of using arg times arg, I could alternatively return pow arg comma 3. And that should still work. Oh, I need a colon. But I think I like having the spaces in there because it's a little easier to see that that's together like that. And that should still work. It still does. I could do the same here, or I wanted to show you composition of functions. So function composition. Composition, or when one function calls another. So x to the 4th power is equal to x squared and then squared again. So I could say answer, double answer, equals, I'm going to call the squaring function with argument. But then I want that squared again, so I can do squaring function again on the outside. And so now I'm sending a function in a function and getting that back, and I can return an answer. So this is function composition, and this is going to, this is something like the function keeps calling itself. If it goes on in perpetuity, it's called recursion. We're going to cover that later. But everything should still work. Our 4th power one was 10,000. And everything is looking good there. So you can call on functions within other functions. It's worth knowing. At the end of the semester, I'll show you how to put the prototypes in a header file and the implementations in a resource file. But that's CSCI 1 endgame shit. We'll do that later. Guess what? We've been using doubles here, but we can have a function that takes in nothing and spits out nothing. So how would that work? When it doesn't take anything in, the argument will be void. And when it doesn't send anything out, the argument will be void. So if it means it's got to do something in there, but it doesn't, it's got to do something. There's no reason to call on it if it doesn't do something. So maybe it prints something to screen. Something that we print to screen is generally like, what the hell does this program do? So we could do a void program description void. And I'll come down to the function implementations and I will implement that. So void program description parentheses void and cout. This program shows using functions and the C math library. Most calculations below were used. Below were done using a 10 as input. I can end line. And now when I want to call it, when you call it in there, you just type in the name of the function. And since it's void, we still need the parentheses, but we're not going to put anything in it. And maybe I'll add another end line here, just to make it look prettier. So now I've got my void program description in the program. I'm going to run it. And it does it. This program shows using fractions in the C math library. Most calculations below were done using a 10 as input. I could be a little bit more wordy and do some cout stuff there. Value squared is the value cubed is, I think we get the picture here. Maybe I'll do something here. Let's comment out the fourth power one. We don't need that anymore. Or the with the 2 in there. Cout the value 2 to the 100th power and now it'll look a little bit better. It looks pretty. I clearly didn't say it to the 4th power. So let's copy that. And we need our insertion operator. Got to make sure we got all our couts and our insertion operators in the right spot. And now it's doing all right. Okay, so some notes that you want to do about fractions, or not fractions, functions. Functions should be simple. They should be specific and targeted. This makes them reusable. And that's called Extensible. You'll hear that word. We're making it extensible if we use it. Notice I didn't make a function that did all of these powers. That's not really reusable. Okay. Run that real quick. Let's take a look at one more thing. Any questions so far? Let's take a look at this stuff here. So I don't really need to show. Yeah, we want to do that one. I need lecture 3A, project 1A. We did stuff there. So I need to just make a new one. Create a new project. Call this notes 3A. And copy paste. So let's go through and read what it's doing. See if we can figure out what the program's going to do without running it. So it includes the IO string. We know it's got to do that. It's including strings, so it's apparently going to use a prompt for a name or something. The function prototype is void output age in dog years. It takes in a string and it takes in an int. Notice that it doesn't say arg in the prototype. What you put there is not as important as just declaring what the types are. Data type is important in the prototype, but not really the variable name, which will show up in implementation. So it's got, we get to the main, it's got string username. So whoever is running the program, we're going to have a username, age. It prompts the user for their name. Cout, enter your name, Getline, cin, username. That's good. Then it asks them for their age. And we'll do cin age. And it does output age in dog years. And it takes in the string. So the string is our X, and Y is the age. So cout, make a couple new lines, print out the name, and then print out the years. I don't like that. I'm going to do this. I'm going to rename this, and I'm going to call this arg name. And now when I look at it, it's telling me it's an argument and it's telling me it's a name. And I can do that here too. Let's say arg age. So it's an argument and it's representing an age. And now the code's a little bit easier to understand when you're looking at it. So cout the name and your age in dog years is age divided by 7. When we go the other way, it tends to be a dog in human years as you multiply the dog's age by 7. So like my dog is around 8 years old, so in human years he'd be 56. check it out. Hefe. Ooh. How old do y'all think I am? Someone give me an age. How old do you think I am?
Not a day over 30.
A day over, not a day over 30. That's a student that wants an A. Was that you, Drew?
Yeah.
Drew wants an A. My actual age, believe it or not, is 46. So my age in dog years is 6. I don't know if I like that. I might think I want to make age a double. Let's make age a double. And since I don't want a bunch of decimal places, maybe I'll include the IO manip library. And when I get down to the C out, I don't need 2 lines for it. I can do fixed. Oop. Set precision. I think 1 decimal place is good enough. Is it going to work? It fucked up. Why? What did I do wrong? Oh, wait. Did it do something wrong? It clearly did, because it was supposed to show decimals, right? We just said 46. I know it's not 6. Something's off. Can anyone tell me what I did wrong here?
Is it because we're doing integer division?
Well, how am I doing integer? I said double age was a double.
In the function?
In the function, that's exactly correct. So even though age was a double here, when I passed it in here, passing in the double into an integer does that round down or floor command. So it was rounding down. And it's treating that as but I entered a whole number, which isn't a problem. But now in here, this has got the round down too. So the way I can fix that is I can change this to I have to change this to a double as well. And since I did it there, notice if I try to run it the way it is, there are build errors. The problem is the carpets don't match the drapes. Drapes up here say double. And so that needs to be, this needs to match down here, string and double. Now let's see if it works. That sounds about right. 46 divided by 7 would be 42 with the remainder 4. Quit showing that. Maybe I should just click don't show me this again. Any questions?
Would you say it's more readable to put argument names in a function prototype or just put the type names?
My personal preference is I like putting the argument names up there because, and this is why, just like we saw in the blackjack thing, there was a lot of code, and if this shit doesn't show up for a while, I don't really know what this string is. So I could do the exact same thing but I could be clearer. And if I say arg name and arg age in human years, well, I don't want to have two of them, so let me void out the other one and show that it still works. Now my arg name matches, but the arg age doesn't match. And I'm 46. David, your age in dog years is 6.6. I think I need a comma after my name. There we go. Does that look a little bit better? This is me being picky with output. There we go. But the question you asked was about that, and I think this is better. I think this is better, as I know what the string and double are for. I know what the arguments represent. Excellent question. Check this out. What if I did something like this? Well, I know it's supposed to spit out my age. What if I do a cout output, age in dog years, username, comma age. Oh, maybe I should end line. Why is it red? Why is this a problem? I wanted to tell the screen my output and age and dog years. What's the coding idea that's wrong in that situation?
Output age and dog years doesn't return anything.
It does. It's exactly correct. Good job, Drew. So this doesn't work because the output age function has a void output or no output, so there's nothing to see out. The see out is actually in the function. So that's not going to work. So I'll comment that out. David. Oh, you said I was 30. I like that. Oh, yeah. It's a lot younger. It's looking good. All right. Any questions? I think that's going to be a wrap